So this is the classics of cryptography and network security. In this class, we are going to discuss about different polyalphabetic substitution cipher. So earlier we have discussed about the monoalphabetic substitution cipher. In monoalphabetic substitution cipher, in place of every character, a new character is substituted based on some algorithm, based on the key. So the key may be a number, or the key may be one character. And we have discussed many drawbacks of monoalphabetic replacement cipher. In monoalphabetic replacement cipher, it is very easy for the attacker to guess. In case of a monoalphabetic replacement cipher, if the attacker is able to create the frequency table of all the characters, then it is very easily breakable. Today we'll discuss about the polyalphabetic substitution cipher. In polyalphabetic substitution cipher, in place of a key, that is either a number or one character, the key will be consisting of a number of characters. Okay. So it is used to improve the security using multiple cipher alphabets, which is making the cryptanalysis harder with more alphabets to guess and flatter the frequency distribution. So to overcome the drawbacks of monoalphabetic substitution ciphers, so this is basically designed. Use a key to select which alphabet is used for each letter of the message, and use each alphabet in turn and repeat from start up to the end of the key is reached. So let's see, one of the best example of this polyalphabetic cipher is Virginia cipher in the next. So Virginia cipher is one of the best polyalphabetic substitution cipher, and it is the simplest one. So it is the simplest polyalphabetic substitution cipher, effectively multiple seizure cipher. The key is multiple letters long, K1, K2, K3 up to KD. The ith letter specifies ith alphabet to use. Use each alphabet in turn. Repeat from start up to the letters in the message, and decryption simply works in the reverse. Let's see. So in Virginia cipher, the encryption, the cipher text CI will be the plain text PI plus the KI, the alphabet of the key, mod 26. And the decryption process will be the PI, that is plain text is equal to, that is cipher text minus cipher text character minus the key mod 26. Let's see one example. Here, write the plain text out, then write the keyword repeated above it. Use each key letter as a seizure cipher key. Encrypt the corresponding plain text letter using the keyword deceptive. Suppose here key is the deceptive, is a polyalphabetic key, and the plain text is this: we are discovered, save yourself. Okay, so the cipher text will be this. For example, I'm showing you one example here. Let's say hello, good morning. So let's say the key is Taj. Okay. So I have to repeatedly write Taj here. Taj. Okay. So the value of H is 7. T is that is T is 19. So 7 plus 9 26, 26 mod 26, that is 0. So in place of H, so this is the plain text, and this is the key, polyalphabetic key, and the cipher text will be A. Now E, E plus A. So the value of E is of 4 plus A is 0, so that is 4. So that is simplest E. Then L plus J. So L is 11 plus J is 9. So 11 and 20. So 20 is EU. So A, E, U. Then L plus T. Then L plus T. So L is 11 plus T is 19. So that is 30. 30 more 26 will be 4. So 4 is E. So another is E. Now O. O. O plus A. So the value of O is 14 plus A is 0. So that is 14. So that is O. So LO becomes this A E U E O. So the same process will be repeated. So that the ciphertext will be this. So this message, in place of this message, okay, cipher message this will be transmitted. And here the key is polyalphabetic cipher. Polyalphabetic, multiple numbers of characters are present in a key. So here T is T is. So you have to repeatedly write the keys till the end. So suppose here it is ended with T. So no issues. You have to ignore A and Z. So in this way we can get the ciphertext. And in the same process, we can decrypt this message. That is so I hope you will complete this 10 sentence. This is very simple, simplest one. So now the ciphertext is given and the key is given. We have to find out the plain text. So this is, so ciphertext is given, that is A E U E O, and the key already you know, that is T A J T A. They ignore the J. So here so plain text, you have to calculate the plain text. So first A plus T. So A is 0 plus T. T is 19. Sorry. That is one of the. So there is a process of decryption. So decryption process is so we have to write the ciphertext. So the ciphertext minus the key mod 26. So this is the we have to generate the plain text character. So here we have to write a minus t mod 26. So that is a minus t. A is 0, 0 minus t. T is 90. T is 90. Mod 26, that we can write it here as 26 minus 90. Mod 26, so that is 7. The 7 is h. The 7 is h. 7 is h. Similarly, e minus a mod 26. So 0 minus, sorry, e is 4, 4, 4 minus 0, that is 4 mod 26, that is equal to 4. So 4 is, that is e. Then u minus j, u minus j mod 26, that u minus j, u is 20 minus j 9, so 11, 11 mod 26, that is also 11, so 11 is a. So similarly, you can make e minus t mod 26. So e is 4 minus t. T is 19, so minus 15. 15 mod 26, which can write it as 26 minus 15 mod 26, that is 11 mod 26. So it is 11. 11, that is L. Similarly, O, you can write it here, O minus A. So that is O. That is O mod 26. So that is 0, sorry, O means that is 14 minus 0 mod 26. That is 0 mod 26. So this is the process of decryption. This is the process of decryption. So next, this is the security of Virginia cipher. Here we have multiple cipher text letters for each plain text letter. Hence, the letter frequencies are obscure, but not totally lost. Start with the letter frequencies. See if look monoalphabetic or not. If not, then need to determine the number of alphabets since they can attach each. So next type of cipher is the transposition cipher. Transposition means that is you have to rearrange permutation. You have to permutate, you have to perform permutation operation. In substitution ciphers, the characters in place of every character, a new character is substituted. But here, in case of transposition cipher, no new characters will be substituted, but only the characters present in the plain text characters will only be rearranged, permutated. That is known as the classical transposition cipher or permutation cipher. These hide the message by rearranging the letter order without altering the actual letters used. Can recognize these the same frequency distribution as the original text. So let's see. So one of the popular classical transposition cipher is Rel-Fan cipher. Write the message letters out diagonally over a number of rows. Then read off the cipher row by row. Then collect the cipher text column by column. So you will get. So suppose here the text is meet me tomorrow. So what I will do in case of relevant cipher, so I will write it column wise. Meet me and I will collect row wise. I have written it column wise and I will read it row wise. So what will happen here? The cipher text. So this is the plain text and this is the plain text. I am rearranging in this way and the cipher text will become MENTMRO and then ETEOORW. So this is the rearrangement relevance. Why it is known as relevance? Because it is dividing into two different rows. So like a trend line, so like this. So that's why it is known as relevance. Then another is that is the row transposition cipher, a more complex transposition cipher than the relevant cipher. So we have just discussed. So here in the row transposition cipher, write letters of the message out in row over a specified number of columns. Then reorder the columns according to the some key before reading of the rows. Suppose here the key is first 3, then 4, then 2. Suppose here these are the keys. Okay. So attack postponed until 2 a.m. The attack postponed until 2 a.m. Okay, so we have to arrange the plain text by using some matrix, let's say 5 plus 3 matrix or 5 plus 4 matrix. Then we have to use this key, and based on this key, so first we have to collect this one, then we have to collect 2, then we have to collect 3, then we have to collect 4, then we have to collect 5, and we have to repeat this process. So it is only the rearrangement. Okay, no substitution. No substitution, only rearrangement. Right. So next is product cipher. The product cipher actually the cipher using substitutions or transposition. If you are not used secure because of the language characteristic, but it will apply both the substitution as well as the transposition. So first substitution, then transposition, or first transposition, then substitution. The two substitution make a more complex substitution. Two transposition make a more complex transposition. But a substitution followed by a transposition makes a new and much harder cipher. This is the bridge from classical to modern encryption algorithms. So the product ciphers are the bridge. These are the modern approach of encryption algorithms. So two substitutions make more complex substitution. Okay, and the substitutions followed by a transposition makes a new much harder cipher. The last one is that is the steganographic method. So steganography means that is hiding something inside another, an alternative to the encryption. So they hide existing messages using only a subset of letters or words in longer message marked in some way. Or we can write something by using invisible ink in a plain paper. Invisible ink, so everybody will think that it is a plain paper, but by using the invisible ink, something have written. Hiding an LSB graphic image or sound file. So the message can be hidden inside a graphic image or a sound file. Can be written. So that means hidden, it will be hidden in some specific multimedia files. But here it has some drawbacks. High overhead is needed to hide relatively few info bits. Okay, so this is the end of this class, and in the next class we'll discuss about the algebra, which are required for cryptography and network security. Okay, thank you.